And I am going to get out of the way now and tell you, first of all, about our first speaker, who is Anthony Ingraffea. And Tony Ingraffea is the Dwight C. Baum Professor of Engineering and a Weiss Presidential Teaching Fellow at Cornell University. He did research and development at Cornell for the oil and gas industry for 25 years, specializing in hydraulic fracture simulation and pipeline safety, and twice won the National Research Council U.S. National Committee for Rock Mechanics Award for research in rock mechanics. He became a fellow of the American Society of Civil Engineers in 1991, became co-editor-in-chief of Engineering Fracture Mechanics in 2005, won the George Irwin Medal for Outstanding Research in Fracture Mechanics in 2006, and in 2009 was named a Fellow of the International Congress on Fracture. Recently, he was named a Fellow, recently he has been deeply engaged in informal education regarding the topic of this lecture with over 100 public presentations. He is also president and a founding member of the Board of Physicians, Scientists, and Engineers for Healthy Energy. Time magazine named him one of its people who mattered in 2011. Please welcome Dr. Tony Ingraffea.
Thank you very much for that gracious introduction, and thank you all for coming out tonight. All the organizers really appreciate the opportunity to once again interact with my fellow citizens from New York on this very important topic. Everybody hears me okay? Not too loud? Just a couple of ground rules. The way things are going to work tonight, each of us are going to talk to you for about 3 hours each, and then there'll be Q&A. That's why all the cookies are in the back. No, we're all going to be very brief because the more important aspect of tonight is the interaction with you, with Q&A. So during my brief talk, I would like you to hold questions unless you hear me say something which is incorrect or wrong. At that point, please let me know and we'll address that situation right away. Otherwise, let's hold off on the Q&A. As you can see, I've slightly changed the title of my talk from the title of this event. Let there be no doubt that where my position is on this. I am a licensed professional engineer in the state of New York, have been for many years, and I took an oath of ethics when I became a licensed professional engineer, and the first canon of that oath is that if I become aware of an engineering process, an engineering act, an engineering technology in the state of New York for which there is a potential for human health impact, I have an ethical obligation to inform the public about it if I know something about it. I do know something about it, and I hope that comes through in the next few minutes. So there are many things that we can talk about having to do with fracking, as long as you and I both understand that when I use the word fracking, I don't just mean hydraulic fracturing. I mean what it's now come to mean. It's a placeholder word for everything involving unconventional development of methane, using the process that we now know is being used just a few miles south of us in Pennsylvania. Unconventional development of methane from multi-well clustered pads using high-volume hydraulic fracturing from long laterals. That's really what I mean by fracking, and I hope you mean the same thing. So I'm going to address three things tonight, as depicted in these pictures. One is what I call the spatial impact of a heavy industrial process. I'm still convinced after 4 years that most people I talk to in New York State don't have an accurate mental image of what the process looks like on the surface. And I don't just mean fracking, I mean the entire thing I just described in 14 words. So I'll address that first, spend a few minutes on it, and then we'll move to something that's obviously of concern to everybody. Water is life. And so we'll talk about the potential impacts on drinking water sources from this activity. And finally, I'll spend a few minutes talking about the impact of shale gas development on climate change. So here are those three topics. The first thing is long-term, spatially intense industrialization. That's another way of describing shale gas development. And I'm going to try to give you a more accurate mental image of what it will look like and what it is becoming like in Pennsylvania and other states. So as you well know by now, this is not like what people call our grandmother's gas wells in New York. There are over 40,000 gas and oil wells that have been drilled and fracked in New York State. That's not the issue. The issue is that none of them have ever tried to produce a hydrocarbon from a shale deposit. To economically and technically produce shale from a shale deposit, one has to use what's depicted in this industry pictograph, which is you have clustered pads, and from each pad you have many wells. The idea being, of course, that there's gas everywhere in the shale, so you want to drill everywhere. So the idea is to pattern the shale with as many wells as you can get investment bankers in New York City to loan you money to drill. So that being the case, what does it really look like? That's Chesapeake's artist rendition. This is an actual photograph taken earlier this year of a well pad undergoing fracturing. There's 4 wells on this one. There will be many wells on pads. It used to be in New York, 1 pad, 1 well. That's not the way it works. As the industry evolves the technology, which it's continuing to do, they're evolving towards more and more wells. Modern pads have up to 20, 24 wells per pad. So that's a typical fracking site. It's not 1 acre. It's not here today, gone tomorrow. That's heavy industrialization that's going to be there for years, because when they're done fracking those 4 wells, and those 4 wells go into production in 5 years from now, their production has gone virtually to nothing, they'll come back and drill and frack 4 more, and then 4 more, and then 4 more, until they've exhausted their ability to extract gas from this pad. I'm often criticized as being too critical of the industry by saying, well, they'll drill everywhere they can. So I want to show you some pictures that prove the point that they will drill everywhere they can, including on mountaintops, and including on the sides of mountains, and if necessary, they will remove sides of mountains to build pads. Again, the gas is everywhere. You've paid a lot of money to landowners as a bonus to get access to that land, and you're going to pay them a lot of money for royalties, so you're not going to hold back on the earth moving. Point here to be made is that if you go to Pennsylvania and you try to visualize what this looks like at what industry calls full build-out of the Marcellus in Pennsylvania is between 100 and 200,000 wells. New York State DEC expects that full build-out of the Marcellus in New York will be somewhere around 50,000 wells. We don't know how many Utica wells, but we're still talking large numbers. Despite the fact that we're talking those large numbers, you're not going to see much in Pennsylvania yet. Pennsylvania only has about 6,700 Marcellus wells drilled. Only about 4,000 of them have been fracked. If they expect between 100 and 200,000, they're just getting started. So it's important to remember that the industry continues to learn with every new well, and they're at the beginning of their learning curve. Still on this intense spatial development, it is important to note that neither Pennsylvania nor Ohio have compulsory integration. Why does New York State need compulsory integration? The industry argues that it must have it, otherwise they can't develop the resource in New York adequately, and yet they're developing it in Pennsylvania and Ohio without compulsory integration. But compulsory integration requires operators and landowners to agree with the DEC to get a permit, for example, to put a pad here and drill 5 wells north-northwest, 5 wells south-southeast in a 1 square mile, 640-acre spacing unit. So now I'm going to try to tell you what this would look like around Elmira if it comes to town. So here's Google Earth Elmira. I think we're right somewhere about in here. Is that about right? Yeah. And each one of these yellow rectangles is a spacing unit. So if gas operators could come to an agreement and not get in each other's way, and if they can get the landowners that control 60% of the land that you see here, then this would be the ideal spatially intense development scenario. No land wasted. There's no empty space between those spacing units. So each red square would be the location of a pad, and from each pad you'd see 5, 10, 15, 20 wells. And yes, some of those wells could literally run underneath the streets of Elmira, depending upon what regulations say about setbacks. And since we don't have any regulations anymore. We don't know what they're going to say. But that's typically what you'd see. You'd see a pad roughly 3/4 of a mile in every direction. Again, I'm criticized by people who say, well, that would never happen. That could happen in Texas. It wouldn't happen here. But it is happening in Tioga County. That's not too far from here, is it? This is Tioga County, Pennsylvania. I guess we're somewhere about over here. And these are spacing units, although they don't call them spacing units in Pennsylvania. And there was no compulsory integration, and there is no compulsory integration in Pennsylvania, and yet the landowners did manage to make arrangements with, in this case, Shell. These are all of Shell's holdings in Tioga County. I'll blow it up so you can see it better. And as you can see, I'm not lying about what would happen to Elmira, because watch this. Here's the town of Mansfield. Oops. There's Mansfield. And here's the town of Wellsboro, and here's Wellsboro. And those towns are surrounded by spacing units, and they will have well pads with many wells per pad. That's just the way the industry works. Okay, enough on that. Let's go to my second topic, impact on drinking water supplies. I'm going to show you data. First, I'll show you a leaking well. For those of you who have never seen one, you've probably heard wells leak sometimes. What does that mean to your drinking water? What does that mean to methane escaping in the atmosphere? I turned down the sound, but this is what's called the production casing, one of the 3, 4, or 5 strings of steel surrounded by cement that are meant to assure us that no possibility will ever exist of a well leaking. Engineers never use the word prevent. Engineers only talk about probability and statistics. So the key question is not, can we prevent a well from leaking? The key question is, what rate of leakage can we expect, given the best available technology? And remember, the oil and gas industry has been doing this 1.8 million times on the face of the earth. 1 million times alone in the United States, 30,000 times in shale gas in the last 10 years. How much more practice do they need? Proof positive they can't prevent it. What the important issue is how frequently can we expect it to happen, and what will the impact be on water supplies? I attended a webinar last week. Well, 2 weeks ago. You know what a webinar is. This one was sponsored by the Society of Petroleum Engineers. I'm a member of the Society of Petroleum Engineers, so I get access to the webinar. The title of the webinar was Wellbore Integrity. That's industry speak for will the well survive what it's supposed to do, which is to produce hydrocarbons only through the well, or will the well fail and lose integrity? Also called loss of zonal isolation, also called sustained casing vent flow, also called sustained casing pressure, also called sustained annular flow, also called sustained annular pressure. Depending upon which paper you want to read, that's what it's called. The well failed. Industry will drill more wells in the next decade than have been drilled in the last 100 years. Global well population, as I said before, is 1.8 million oil and gas wells, of which roughly 35% are leaking. Now, I didn't say that. This is an official representative of the Society of Petroleum Engineers who was invited to give a talk to other engineers, members, about what the problem is with wellbore integrity. It's not a small problem. All right, so last piece of data. Pennsylvania Department of Environmental Protection, since about 2009, has been assembling and making available to the public data about the Marcellus wells being drilled and put into production in Pennsylvania. Among that data set is data concerning violations of regulations. It is a violation of regulation in Pennsylvania for a well to leak. I want to make sure you understand that. It is illegal in Pennsylvania to have an oil or gas well leak. So I went into the database, and with my associate Renee Santoro, when he went through all 6,700 well records from 2010 all the way up to the end of 2012, and we counted the number of times the Pennsylvania DEP had issued a violation because a well leaked. And we found a few. And then we realized that that can't be right, because there are more consent orders issued by the Pennsylvania Department of Environmental Protection against operators who have caused their wells to leak and therefore have contaminated private water supplies than there were in the database about violations. In fact, many of the wells that were subject of consent orders, and those of you who don't know what a consent order is, we can talk about that during Q&A. How could a well that was a subject of a consent order not be in the violations database? And the answer is just because a well is leaking and it's illegal, you don't get a violation. Because in 2010, DEP made a new protocol, which is inspectors in the field are not allowed to issue violations without first sending them to Harrisburg for approval. So then we went back through the database again with a new protocol, which says, let's look at the inspector comments. So when an inspector goes to the well, he, she writes comments. And we found many instances in which the inspector says, this well is leaking. There's bubbling in the cellar. There's methane being emitted, but there was no violation. So when we count up all the wells that were seen to be leaking, this is what we find. In 2012, roughly 9% of all the new wells drilled were leaking. New wells, not 30-year-old wells, not 5-year-old wells, new wells. Marcellus and Utica, somewhere between 50 and 100,000 wells expected in New York. You do the math. How many wells are going to leak in New York? According to statistical evidence of performance of the same operators who are operating south of us, who will come across the line using the same technologies, the same drilling, the same cementing, the same casing, the same protocols, the same people, the same materials. Why should we expect anything different? Because Albany writes tougher regulations? Pennsylvania has tougher regulations by definition because we don't have any. And every state right now is falling over itself trying to say we've got the toughest regulations, but regulations don't stop things from happening. There is a very well-known, well-worn set of regulations. They're called the 10 Commandments. Thou shalt not steal does not mean that no one will ever steal. Thou shalt not steal has an effect if there's a policeman who could catch you stealing. The analogy here is if there's an inspector that sees a well is leaking, but if that policeman sees you stealing and says, don't do it anymore, chances are pretty good you might do it again. So unless you have to have the tight regulations, then you have to have tight inspection, and then you have to have an enforcement which is proportional to the harm. So if 16 families lose access to their water well in Bradford County, and I can show you the consent order, which is a legal document in which Pennsylvania declares that one operator caused 16 families to lose their water well. No, it's not Dimmick. That was 13 families. Those 16 families lost their water wells, and the company was fined $900,000. How much gas was produced by those 16 gas wells? Hundreds of millions of dollars. Is the fine proportional to the harm? So where is the motivation for a company to do a better job and fix things and pay people their just desserts when they're harmed? Okay, last comment. Worsen climate instability. Notice I didn't say climate change, I didn't say global warming. Those are too nice. Some people think global warming is good, especially in upstate New York. Climate change, weather changes, why shouldn't climate change? What we're really worried about is climate instability, the ability not to be able to predict over a long term and a large region what will be the effects of climate. So, you all know that carbon dioxide is increasing in the atmosphere over time. This is my obligatory graph phase of the talk. Time, concentration of carbon dioxide, everybody knows that. Some people are concerned about it. Most are, some aren't. Methane concentration in the atmosphere. Speaking of hockey sticks, not too many people know that methane concentration has doubled since the Industrial Revolution. Gee, what happened during the Industrial Revolution? Humans started putting a lot of methane in the atmosphere. So what? Methane is much more potent as a greenhouse gas than carbon dioxide. How much more potent? Depends upon how long you're willing to wait. If you're willing to wait 100 years, it's 33 times more potent. One molecule of methane traps as much heat in the atmosphere as 33 molecules of carbon dioxide. That's bad. If you only want to wait 20 years, and I'll give you a reason why we shouldn't be waiting as long as 20 years, then that factor goes up to over 100, which means if you're leaking, venting, not burning a small quantity of methane, that's the same effect as burning a large quantity of carbon dioxide. Does methane leak during shale gas development? Sure does. I'm not going to show any videos tonight, no time, but I would point out that partly as a result of a paper that 3 of us at Cornell wrote 2 years ago, in which we strongly encouraged the government, regulators, and researchers around the world to go out and start measuring how much is leaking, because we don't know. Literally, as I stand here tonight, no one on the face of the earth can tell us how much methane is leaking because of shale gas production. We don't know. But we set the policy in motion to go ahead and do it without knowing what the scientific consequences are yet. So starting 2 years ago, people went out and started making measurements. And these are measurements made by your federal government, National Oceanic and Atmospheric Administration, Utah, Colorado. Those numbers are not dissimilar to what we predicted would likely be the case. Recently, you've read articles, I hope you read articles in the newspapers and magazines about measurements that are being made in our cities. Here's downtown Boston. Everybody in this room right now, take a breath. 2 parts per million of what you just breathed is methane. That's the natural background level of methane in the Earth's atmosphere. That's normal, that's natural. That's everything that's in red. Everything that's in yellow is higher than that. Some cases, much higher, 15 times higher. Where's the methane coming from? Leaking underground gas lines. Have you had a leaking underground gas line anywhere around Elmira recently? Okay, how old are these gas lines? Older than most people in this room, including me. How much would it cost to dig them all up and replace them? Okay, so there's a lot of methane leaking. Bottom line, last slide. Takes forever to go through this, so I'm going to go real quickly. Year, average Earth temperature change, measurements. 2010, we were 0.8 of a degree centigrade warmer than baseline. Global warming is happening, and it's causing climate instabilities. We don't want to get into the warning zone, and we certainly don't want to get into the danger zone. This is a computer simulation prediction of how long it's going to take with business as usual. Keep producing and burning coal, oil, natural gas. Computer models say we're going to be there in 2042. That's not 100 years from now. Okay. So what we should be doing is drastically decreasing the amount of fossil fuels we're using. And the computer models say then we would be doing this. And the one fossil fuel to which these computer models are most sensitive, methane. Because it's much more potent as a greenhouse gas and has its deleterious effect on the climate much sooner than carbon dioxide. The single quickest thing we can do to slow down climate change would be to decrease methane emissions into the atmosphere. There's a way to do that. 2 of us here tonight are co-authors on a paper that came out just a couple weeks ago on how to convert New York State by 2030 to almost a completely fossil fuel-free state. And it would take that much new jobs. Some of you are reading that and saying, wow, 4,000 5-megawatt turbines onshore, 12,000 offshore, 3,700 megawatt solar panel. Where are we going to get money to do that? Where the hell did we get the money to do that? It's all somebody's money. In your retirement account, somebody on Wall Street is saying, we're going to loan Chesapeake $5 million to drill another well in Pennsylvania tonight. That's your money. You get those people on Wall Street to start saying, no, we'd rather do this. And by the way, we're going to put a lot of people to work in New York State doing it, including people in Chemung County. And those jobs won't be done by people coming from Texas and Oklahoma. You don't have to be a roughneck to do this sort of stuff. Okay, so there is a better plan. And hopefully we can ask more questions about it tonight, but at this point I want to hand off to Dr. Barth to continue the next part of the presentation. Thank you for your attention.
Thank you very much, Tony.